So now that we know more about lines and line segments, and we talked a little bit about rays, we can now start looking at angles and how lines and line segments and rays form angles. But let's first talk about the ray again and go into a little bit more detail as to how we label our rays. So once again, a ray is part of a line. So part of a line that is extended infinitely. So there's our symbol for infinite in one direction. It only has one endpoint. So there's one endpoint. As for a line segment we talked about up here, had two endpoints. So a ray has one endpoint and then it goes on forever. So now all rays are named by 2 points. The endpoint and another point on the line. Or on the ray, sorry. So if we look at the above ray here, this picture here, we have our definite endpoint, which is A. So we do start with the endpoint first. But we also have 2 other points on the line in B and C. So it would be totally okay to name this ray AB or ray AC. Both would technically be correct. So just to go over it, if we had line segment AB, so this is a line segment, we would label it AB with a line above. Array AB, so one endpoint, this would be labeled AB with an arrow above, or you literally draw array on top of it. And then a line would be forever in both directions. We pick 2 points, there are no endpoints, and we would label it as such by drawing a line on top. So that's the difference here. So now we know what a ray is. Now let's go and look at how an angle is formed. So if we go down here, so an angle is formed by 2 rays that have a common endpoint. So let's take a look at this diagram below. So what 2 rays make up this angle? So we have 2 rays with a common endpoint, like we just said. So we have this ray here and this ray here. So how do we label them? So like I just said when we went over the labeling, we first say the endpoint, then another point on the line. So we have ray ML and also ray MN make up that angle. So what point do both rays have in common? They both have this point M in common, the same endpoint. So this common point is called the vertex of an angle. So that's where the 2 rays meet. And then how many parts does an angle separate to, or separate a plane into? This would separate a plane into 3 separate parts. So we have some angle down here. Let's say it's angle LMN. So angle LMN. We're going to go over the naming in a second. So the most important part here is to see what the plane is broken up into. So let's say this is also called angle 1. There's a couple ways we can name this as well, but the parts that this is broken up to is first the interior, meaning the inside the angle or in between the ray, both rays, or we have the exterior, the outside of the angle, what's not inside of it. So we have the exterior of the angle. And then one more thing we have, so this is the third, would be any points that are on the angle. So any points here, here, here. So we have anything that's on the interior, exterior, or on the angle. So those are the 3 that it separates a plane into. Now, let's get to the naming part. So the way we name an angle is by first stating points on the rays with the vertex in the center. So the vertex will always be the middle letter when we name an angle. So let's go ahead and name this here. So we had our points, we called it angle LMN, like I said up here. So we have L, M, and N. Our vertex always goes in the middle. So LMN would be appropriate for a name. Also, we can call it angle NML and go the other way. So the vertex is always in the middle. And then also you might see an instance where we have an angle labeled by a number. So let's say this was angle 1. You might have to call it angle 1 to be easier. So it really depends. If you're given points on the ray and a label for the vertex, you can label it that way. Or if there is a number for the angle, you could go ahead and do that. So we do have a bunch of different types of angles we're going to get into. Now, not all angles obviously have the same degree measures, but we do have a few special ones that we're going to commonly see. So the first one we're going to talk about is going to be a straight angle. So a straight angle is an angle that is formed by two opposite rays, meaning two rays that go in the opposite direction, literally. So opposite rays, like I just said, are two rays that have a common vertex and go in the exact opposite direction. Straight angles will always measure 100 degrees. So 180 degrees, sorry. So let's elaborate on that a little bit. So they labeled or measured to 180 degrees. So let's pretend that I have this straight angle here. Again, it's just a straight line. So let's say my vertex is B, and then I have a point here, A, and a point here, C. So we have two rays that are connected. Here's my ray BC, and then I also have my ray BA. So let's go ahead and label that. So this angle, or straight angle, is formed by rays BA and ray BC. Okay? So just because it's straight, it still has that 180 degree measurement. You might not think it's an angle because it doesn't look bent like you would see a typical angle, but as we set up here, it does share a common vertex, okay? So B is that common vertex. So that means this angle here is 180 degrees, and here is my vertex, which is created by two rays. So that's a straight angle. Our next angle is an obtuse angle. You might have heard of these before. An obtuse angle is an angle with a measurement that is greater than 90 degrees. So a couple of examples. Typically, an obtuse angle would look something like this. Greater than 90 degrees, let's say it's 130. Maybe we'll see one facing this direction. Looks like this. Say it's 120. It's just an angle that's greater than 90 degrees. Pretty straightforward. And then we have our right angle. Our right angle is an angle with a measurement of exactly 90 degrees. So again, it'll look something like this with that box there. As soon as you see this label with the box in the corner of an angle, that means it's 90 degrees and it's a right angle. So again, it could face any direction. It could look like this. It could also look like this. As long as it has that box there, that means it's 90 degrees. A couple more angles. We have acute angles. So besides obtuse and right, acute angles are ones that are less than 90 degrees. So when I think of acute, I think of small. Acute means something small probably. So we have an angle less than 90 degrees. So let's say an angle is 30 degrees. We can have an angle that's 89 degrees. That is an angle that is acute. So congruent angles. So any congruent angles are two or more angles with the same measure. So our common label for congruent, you might see something that looks like this. It's an equal sign with a little squiggly on top of it. That means congruent. So any two angles or any two or more angles with the same measure would be congruent. They can be in a different direction. So as long as they're the same degree measurement, so let's say that one's 30 and this one's 30, they are congruent. Okay? And now angle bisector, we will see this again in a couple of lessons, but I just wanted to bring it up now. An angle bisector is a line, ray, or segment that divides the angle into two congruent angles. So a picture for you would be something like this. Let's say I have angle ABC here. That's 60 degrees. Now, Let's say I bisect this angle ABC with, like the definition says, a ray, let's call it ray BD. So if it bisects it, it divides it into two congruent angles. So if they're two congruent angles and we bisected it, that means one would be 30 and one would be 30. So the notation for this, or in words, would be, you could obviously say that now ABD is congruent to angle DBC, but you would say that the ray BD bisects angle ABC. Okay, so let's move on down. So now we have some practice here. So what I want you to do is just look at these angles. Yes, I know we're not exactly measuring them and they're not drawn to scale, but just to get a general idea, I want you to take a look, practice these for a second, and then pause it. We'll pause the video first, then practice, and then we'll go over them. So to go over these, what types of angles are they? Acute, obtuse, straight, or right? Let's take a look. So this angle kind of looks like it's less than 90 degrees. So we could say that angle MAN, let's properly name them, or angle NAM is acute. It's less than 90, right? Let's take a look at this angle here. We can call this angle PDO or angle ODP. Remember, the vertex is always the center or the middle letter when we name the angle. So this looks like it should be a right angle. Again, these are not drawn to scale. This is just for practice to get used to looking at them. We're going to say this is a right angle here. Looks like it's equal to 90 degrees. Now here, this should be a gimme. We have two rays with a common vertex. Look at your definition of a straight angle. If you forget, we can call this angle QGR or angle RGQ, and this is a straight angle. And then finally, to name this angle, we have angle SJT or angle TJS, and this looks like it's greater than 90 degrees, so it is an obtuse angle. Another type of angle we're going to look at now and also see again not too far in the future is a vertical angle. So what are vertical angles? This might be something that's a little bit newer. So vertical angles are angles that are opposite each other where two straight lines cross. So vertical angles come in pairs. If we look at the diagram below, there are two pairs of vertical angles. So once again, they come in pairs. So there should be two vertical angles when we're describing them. So by definition, it says they are opposite each other. So this angle here and this angle here are opposite each other, formed by two straight lines. So those are two vertical angles. So to label them, we could say angle GEH and angle FEM is a pair, as well as these two opposite angles. They are vertical angles, angle GEH, or GEF, I'm sorry, and angle HEM. Okay? So why did I draw these two lines for this one and one line for those? So when we talk about angles being congruent, if I were to draw one line here and I wanted to show that the opposite angle was congruent, I'd have to draw the same amount of arcs or angle measures for this opposite angle. So when we talk about these two opposite angles now, GEF and HEM, we'd have to use a different label because these are congruent to each other. So make sure you look at those arcs we use for angle measurements. So vertical angles are congruent. And again, the symbol we use for congruent looks like that equal sign with a squiggly line on top. Pretty simple, but also remember when labeling in the picture what I said about this here. When we show two angles are congruent, we have to make sure we put the same amount of arcs or tick marks inside of the angle. So now let's go ahead and apply this to some diagrams with some actual numbers. So if we look at the diagram up here, what is the measure of angle GEF? So if we look at what we just labeled before, we said that when two lines meet or two lines cross, it creates vertical angles, two straight lines. So the opposite angles, or the pair of vertical angles, are congruent. So that must be equal to FEM. GEF and FEM are the same, and also GEF, HEM are the same. So we have our opposite angles here and our opposite angles there. So what is the measure of angle GEF? GEF is opposite 145, so this would be 145. Same thing goes for angle MEF. So MEF is opposite GEH. It's 35 degrees. Now, there's something you might notice here. It might not be too quick to pick up, but what do you notice about angles that are next to each other or adjacent? This is something that will come up in the future. So 35 and 145 are next to each other. What do you notice about them? One thing that's not noticed so quickly is that when you add them together, they do equal 180 degrees. Now, why is that? That's because we have a straight angle there, right? If we draw just this part here, G, E, M, and H, it looks like a straight angle upside down, like we spoke about before. We just have another right coming off of it. So those two angles always add to 180 degrees. Any two angles on a straight line will add up to 180 degrees. So now let's take a look here. Let's practice. So we're going to go across here, across the chart. So basically we have 4 different problems here. We have 1, 2, 3, 4. So if GEF is 120 degrees, what's FEM? Well, I'd like to first look at the vertical angles, or the pairs of vertical angles that we have. So if that's 120, that has to be 120. And what I just said before is that adjacent angles, so this angle and this angle, you could look at these two angles, they have to add to 180. So this missing angle here has to be 60. So does this angle. It's another vertical angle. So all it is the opposite angles are congruent, and the ones next to each other add to 180. So if we had to fill that in, we would say that angle HEG, so this angle here, we just solved is 60. Angle FEM was also 60. And then angle MEH was 120. So we repeat the same process for all of these. Now we're just given different numbers. So if you want to practice, you can go ahead. You can pause the video. I'm going to fill in the numbers for you. So I will put the answers in here. These are pretty self-explanatory. If you want to go back and watch the first example, that would be great. So if I fill in the answers here, again, angles that are next to each other or adjacent add to 180, and opposite angles are congruent because they're vertical angles. Oops. So let's move on. We could apply a couple more things here. So as you can see, we have some algebra involved now. So if we have some algebra involved, we're not going to just forget what we just learned about what vertical angles are. So we could apply the same concepts. So here we're solving for the missing variable x. Again, we have two vertical angles. Opposite angles here are congruent. So what I do is I set 2x plus 6 equal to 96. Subtract. And I get x equals 45. Simple setup. We just have to remember what our rules are. Same thing goes for here. We have another pair of vertical angles. That means they are congruent. We just have some different algebra. We set equal and solve. I get x equals 8. But remember, we need to find angle BEF, so we have to plug back in. Angle BEF is equal to 2x plus 24. So I go ahead and I plug 8 in, and I get that my angle is 40 degrees. Remember, we have to look back and see what they're asking for. For this one, they asked for BEF. This one, they just asked for X. Now, my last one here, I want to solve for angle GEH and angle HEM. So that's these two angles here. So what did I say before? They're two adjacent angles. They are in a straight angle. So that means when we add them, they equal 180 degrees. So let's go ahead and do that now. So the setup, x plus 20 plus the other angle, 2x plus 40 equals 180. Now I combine like terms. I have 3x plus 60 equals 180, minus 60, and minus 60. I get x equals 40. But again, I have to find these angles here, so I have to plug back in. So angle GEH was equal to x plus 20. Angle HEM was equal to 2x plus 40. Now let's plug that 40 back in. So I have 40 plus 20. I get 60 degrees. And then I get 2 times 40 plus 40. And that is equal to 120. So there you go. That's how you would solve for those. Remember, your vertical angles are congruent. When they're adjacent on a straight angle, they add to 180.